Okay, so I'm going to share my screen. Okay, so we want to find out distance from shortest distance from one node to every other node. Okay, so let me draw that network. So we have some, I think, total 11 nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it is like this. Okay, so next this one. Shall we do not like this with circles? Is that correct? Is that good? So these are circles are the vertices, okay? And what are the other things? These two are connected. These two are connected. And these two are connected. These two are connected. These two are connected. These two are connected. Did I give all the edges? No. These two are connected. These two are connected. Did I give all the edges? No. Look at your graph.
Yes, sir.
Okay. So what are the edge weights? Edge weights are 2, 8, 7. Is it? I think this is 1, right? This edge weight is 1. And this is a 6. This is 7. And this is 1. This is 5. This is 5. And this is 2. And this is 9. And this is 2. This is 9. This is 9. And it is 3. And it is 6. This is 2. And this is 3. And this is 1. And this is 7. This is 1. And this is 2. And this is 10. And this is 4. Am I right? These are the values I gave.
Yes, sir.
Okay, so how many vertices are there? What is the new? New equal to number of vertices equal to 11. 11. Am I right? Total number of vertices are 11. And you can see the algorithm stops as and when the index I reaches new minus 1. That means whenever I becomes 10, the algorithm stops. Okay. So we want to start with one initial node, and from that we want to compute the distance from shortest distance from to all other nodes. Okay, so I'm going to take some initialization. So initially so let us say I'm selecting this node. Okay, so I'm selecting this node. So let us call this as u naught. So I'm not given the names to these vertices like as I did yesterday, v1, v2. I think that is irrelevant, right? So naming a node two times mere waste. As and when we identify the new node, we shall label that vertex with the this one. Okay. So, so what the discuss algorithm? I want to find out shortest distance from this node to this node. I want to find out the shortest distance from this node to this node. I want to find out the shortest distance from this node to this node. Like that, I want to find out the shortest distance. Okay, weighted distance. Okay, from this node to every other node in the network. Okay, so for that we started with the initialization. Okay, so what is that initialization? So we started with the index number I. Okay, and in that okay, we started with the set s. Okay, in that set s we put u naught. Okay, initially we have identified, we labeled L of u naught as 0 because the distance from u naught to u naught, there is no distance, so you may think that like that, so it is obviously 0. Okay, so we initially labeled this as 0. Okay, now what is the next thing? So you have to prepare a minimum of L of I. First you have to compute L of I, L of Vi. Okay, so what is L of Vi initially? So the rest of the things. Okay, so VIs are the elements of the vertices. VIs are the vertices which are not there in this set. Okay, so which are not there in this set means S complement, Si complement. That means these are all the vertices. Initially, we'll be assigning infinity. Okay, so that means we initially will assuming that there is infinite distance from this vertex to this vertex. We'll assume that there is an infinite distance from this vertex to this vertex. So what is the initialization? L of u naught equal to 0 and L of and S naught is assigned with u naught, and we assumed that L of Vi equal to infinity for all, let us say why to say Vi, let us say V. Okay, and we assume that L of V equal to infinity for all V belongs to S naught complement, S naught complement. Okay, so that is the initialization. That is the initialization. What is S naught complement? V minus S naught. That means V minus the set of vertices minus the initial vertex u naught. Okay, now so now what you do, you take each vertex in Si complement. Okay, Si complement is these vertices. You take this vertex and see the distance from this to this. See the minimum distance from this to this. Take this vertex, see the minimum distance from this vertex to this. Take this vertex, compute the distance from minimum distance from this vertex to this vertex. So like that you assign minimum distances to each of the node. After assigning the distances, okay, among these distances identify the vertex which with minimum distance. Let us say this is having two distance. Let us say this is having three distance, this is having four distance, five distance, six distance. Six distance is the shortest distance from this node to this node. Okay, so among all these nodes, which node is really shortest? That means minimum of minimum distances. Okay, so L of V is finding the minimum distance from this vertex to u naught. Like that, find out minimum distance, find out the shortest distance from for every node. Among all those nodes, you identify the node which is having the shortest distance. That distance you write down. So that means what? Here I have to write it as minimum of L of V such that V belongs to Si complement. Such that V belongs to Si complement. Okay, then you identify that node, add that node to the Si for the next iteration, or here itself. Okay, so for the next iteration of Si. Okay, so in the first stage, now let us take this node. What is the distance from this node to this? 2. Can you see?
Yes, sir.
What is the distance from this node to this?
8.
What is the distance from this node to this?
1.
1. Okay, and what is the distance from this node to this? Shortest distance. You tell me the shortest distance. There are several distances.
3, sir.
3. Okay, so you previously you remember it as this is 2 and this is 8, this is 1, now this is 3. Shortest distance from this node to this is 3. Am I right? 2 plus 1 is 3. You can see among all possible paths. Am I right? Similarly, what is the next one? This node is you see some. I think it may be 2 2
6, sir.
something 6, this one only, right, along this path only. Like that you assign distances, shortest distance from this node to every node of this, for every node. Among all these things, which node is really nearer to u naught? You tell me.
1,
This
sir.
one, correct, this one, right? So you call this as u1 for the next iteration. You call this as u1. Is it clear? So for the next iteration, which node I am selecting? The node which is really short when compared to all other nodes. So I'm going to call this as U1. Okay, so my next node is U1, and the minimum distance from one to U1 to U0 is 1. Am I right? So
Yes, sir.
in the new set, you keep in the next set, in the successive iteration, we add this node to the set. So that means what? U0 and U1, and you keep track of these lengths here. Okay, that may be easier for us. So L of U0 is 0. Now L of U1. What is L of U1? Is 1. Is that okay? Now come to the next iteration. Now I becoming 1. In the algorithm, when you are writing the program, in the while loop, you will write I equal I plus 1, right? Now here we are not writing that. Directly we are incrementing it. Okay. So I equal to 1. Okay. Now what is your updated set? Your updated set is U0 and U1. Now what you have to do in this iteration, now these are that two nodes in the two vertices in this set. Now rest of the vertices are this. Now what you do, you assign distance, okay, which is the shortest to one of these nodes. Okay, let us say distance from this node to this node is let us say 10 for the time being, for that for the understanding. Let us say this is 10, and from the distance from this node to this node is let us say 12. Okay, then which node you are going to select?
U0.
This one. This, so you will be assigning 10 to this node, not 12. Is it okay? Okay, so in this case, uh, as the values are already there, what is the distance from this node to this node? Already 2, right? And what is the distance from this node to this node? You tell me. 6 plus 6 plus 7, 13 along this path, let us say. 6 plus 7, 13. Okay, and our aim is not to find out the distance from this node to this node. Our aim is to find out the distance from this node to the source node. What is our source node? U0. My aim is always to compute the shortest distance from source node to any other node. Okay, so when you are measuring the distance from this node to other than the source node which is there in Si, then that distance to be added to already the length that is assigned to U1, that means 1. So if I am computing the distance from this node to this node, that distance to be added with already the distance that is there for U1. Okay, because I want to reach to this U0, not to this one. So if I can reach from this node to this node, I know how to reach this from this node to this node in a shortest way. That's the idea. Am I right? So if that is the case, 13 plus 1 is 14. 14 is longer, but this is 2 is shorter. Is that okay? So I will prefer to go along this path or along this path. Okay. So this distance is going to be 2. Let us take let us say this distance. Okay. What is this distance? Okay, it is sufficient to measure the distance. Now you have to measure the distance from this to directly this, and measure the distance from this to this, and add the distance from this to this, so that you will get the distance from this to source node via U0. And among those distances, which distance is shorter, you assign that value to this node. Okay, for example, to this node, what is the distance? If you are going direct along this path, 2 plus 1 is 3. But if you want to reach along this path, so 3 plus 2 is 5. 5 plus 9 is 14. 14 is the walk length. 14 is the walk length from this point to this point, and that walk length you add with already existing value. Okay, so that is what you see in the algorithm. L of y is the walk length. You see, ui to vi plus L of ui. Okay, either that, okay, or L of E, which is already existing to that. Okay, so walk length is U1 to this node, okay, plus already U1 is there. Okay, you add that one. So idea is to explore the shortest distance from one node to every from one node to the source node. Okay, that source node either you are exploring, or you are exploring through some intermediate node which is already we explored, is the question. Okay, so which node you want to select next? Which one you think is nearer to u naught?
2.
This node, right? This node distance is 2 to u naught, and that is lesser than any other node that you take. You take any other node, you compute the distance from that node to the u naught either directly or via the existing intermediate nodes. The distances are always more than this. So this is the minimum of all other distances which are assigned to the other nodes. Therefore, for the next iteration, I'm going to take this distance. Okay, so I'm going to assign this as u2. Okay, so this is u2. And what is L of u2? Now L of u2 is 2. Okay, so L of u2 means L of u2 means it is the distance from u2 to the u2 to the source node. L of u1 is the distance from u1 to the source node. Similarly, L of u3 will be the distance from u3 to the source node. So we are making so those are nothing but these distances only. Okay, so those distances I am writing horizontally by specifying the in terms of L, but here I am not mentioning this. Okay, so so what now, what is your new set? Your new set is going to be u0, u1 and u2. Now we updated this set. Okay, now for the next iteration, it is now I becoming 2. Now my new set is u0, u1 and u2. Okay, now rest of the vertices are these things. Okay, so among these vertices, you find out the shortest distance from each vertex to the uh, source node, either directly or via through intermediate nodes. Among all those shortest distances, you identify the node which is really shortest to the u naught. Okay, so what is this node distance? This node distance to source is 8. Can you see that? And if you are taking this node, it is sufficient to measure the distance this node to u2, because already u2 distance, shortest distance I know. I will add that to this distance. Now what is this? If I am comparing this with this node, so from distance walk length from this node to this node is 1, and the walk length from the shortest distance from u2 to u0 is already 2. So total length to reach from this node to the source node is going to be 2 plus 1 3. Okay, so this is 2 plus 1 3, and that is 3 is lesser than any other path to reach u0. Okay, and this shortest distance is 3. What about this node? 2.
6.
So whatever the path you take, that is more than 3. Can you see that? For every other node, the distance from that node to reaching the source node is more than this 3 distance. Do you agree? Am I right or not?
Yes, sir.
So for the next iteration, what will be my next node? It is going to be this one, u3. Okay, so what is L of u3? L of u3 is going to be 3. So I'm going to write down that one. So the distance from source node u0 to u3 is distance is 3. So I selected u3. So u0, u1, u2, u3. So I think I don't need to keep track of this, because this one and this one are one and the same. L of u1 is 1, L of u2 is 2, L of u3 is 3. L of u3 means that is the shortest distance from node u3 to source node is 3. That is understood from this. The shortest distance from this node to the source node is 3. 2 plus 1 3. Okay, so I think I can erase this, because already that track is there in the table itself. Okay, so this is already I have written. Okay, so now what is the next thing to do? Now next iteration is 3. Now updated set is u0, u1, u2 and u3. Now We have 4 vertices already. Remaining are 7 vertices. Among these 7 vertices, you identify the vertex which is nearest to the source node. Okay. So for that, you need to find out the shortest distance from each node to the uh, source node. Among those distances, you find out the minimum distance. That corresponding node is going to be the nearest to the source node. Okay. Among the rest of the nodes. So from the, if you take this node, what is the distance from this node to U0? 8. Can you see that? Hmm?
Yes, sir.
Similarly,
Yes, sir.
if you take this node, what could be the distance? 3
Six.
plus 1, 4. 4 plus 2 is 6. Along this way, it is 6, shortest distance. But I don't need to compute all these things. I just, because it is nearer to this node, I just have to compute the walk length from this node to this node, and uh, to that walk length you already add the walk length that is there for L of U3. That means 3 plus L of U3. So what is L of U3? Already we have 3. So 3 plus L of
3.
U3 is 6. That 6 is nothing but the distance from this node to the source node. Is that clear?
Yes, sir.
Suppose if I am measuring the walk length from this node to this node, okay, then what is the distance? You can reach to this node either through this way or through this way. Okay, if I am going in this way, 7 plus 5, 12. 12 plus already existing shortest length. 12 plus 1 is 13. Okay, 12 plus 1 is 13. If you are going along this way, and that is going to be 11. 11 plus 1 is 12. Okay, so among like that you explore all possible paths. Okay, from this node to, see, because this is a smaller network, with eyes we are able to see it. But if you have a larger network, if you have hundreds or thousands of network, like this you cannot explore, right? That's why algorithm will come into picture. You write a code, you give the instructions uh, uh, in such a way that you assign uh, distance from shortest distance from source node to every node. Then among all those distances, identify the vertex which is having minimum distance from the source node. That you select it as ui plus 1. Okay. So aim is not to just do it manually. The procedure should be understood through algorithm, because while writing the code here for I set, I will be able to see because this is nearer, this is nearer, I can explore through eye. So that I don't need to explore all these things. Okay, but computer doesn't know, no, whether this is nearer or this is nearer or this is near. When you're writing the algorithm, that algorithm will check for every other node. Okay, that is for each of the element other than Si. Then only it can decide. It cannot decide just like our intuition or by eye set. Do you understand what I'm trying to say?
Yes, sir.
Right. So then, so for the next, so we explored 1, 2, 3, 4 data points. Now we have to select the fifth data point. Okay. So this is 8, or this is 8, this is 8. Okay. So among these things, which node you think is nearer to the source node when compared to all other nodes?
Node to the right
U3
of
with
U3,
2.
sir.
Is this the node?
No, sir.
No, sir.
Which one? This one?
U3
Yes,
with
sir.
weighting. Yes,
This
sir.
one? So walk length from this node to this node is 2, and 2 plus length of U3 is already 3. 3 plus 2 is 5. Am I right? So is that 5 lesser than any other length from source node in the remaining vertices? Is that right? I think that is correct, right? So for the next iteration, what is my next node? This is going to be U4. So when this is U4, so that distance is walk length plus shortest distance from U3 to source node. Okay, that is L of U3, which is 3. 3 plus 2 is 5. Okay, so for the next iteration, this is going to be so this is 5 and this is U4. What do you mean by this? The shortest distance from U0 to U4 is going to be the 5. So what is my new set? New set is U0, U1, and so on up to U4. Is that okay? U1, U2, U3, U4. So for the next iteration, it is going to be U1 to U4, and now we explored. It is not U1, sorry, U0 to U4. So far we explored five nodes. 1, 2, 3, 4, 5. Okay, now explore the remaining nodes. Identify the node which is nearest to the source node when compared to all other nodes. Which node do you think is nearest?
Center one, sir.
Is this the one? So what is the
Yes.
walk length from this node to this node? 3. 3 plus shortest distance from U3 to U0 is 3. 3 plus 3 is 6. Is that 6 minimum when compared to all other nodes? You just see.
Yes, sir.
Am I right? So for the next iteration, I'm going to call this as U5. So when I say this is U5, what is that distance? 3 plus 3 is 6. Okay, so for the next iteration it is 6. So I'm calling that node as U5. Updated set is U0 to U5. Now copy the same thing to the next iteration. So U0 to U5. Now we explored 6 nodes. Okay. Okay. So after U5, identify the node which is nearest to the source node through the intermediate nodes or directly to the node. Which one do you think is nearest?
Two
Among
possibilities are there, sir.
rest of the things, this node, this node, this is explored. No, 1, 2, 3, 4, 5. Tell me,
Two possibilities are there,
what are
sir.
those? What are those?
From U0 directly with 8.
This one.
Yes, sir.
Okay.
And below U5 with 2.
Right.
2. Okay. So this
Yes.
weight is already 6. So walk length from this node to this node is 2. 2 plus shortest distance from U5 to U0 is U5 to U0 is via this, which is 6. 6 plus 2 is 8. So 8 is a minimum when compared to all other nodes. Is that right?
Yes,
Either
sir.
you have to explore this, you have to explore this. Other than these two, if you take any other node, the distance will be obviously more than this because they are far away from these nodes through the visual analysis. But for computer analysis, it has to measure each node distance to the source node. Okay. So which one you want me to take? This node or this node? You tell me. 8 edge node or
U0
via
directly
U5?
with.
You not directly with this one. So
Yes.
if I am calling this as U6, if I am calling this as U6, then what is that distance? 8,
8.
8. Okay, so this is 8. So that is U6. So it is going to be U0 to U6. And next iteration also we know because both are having same things as you said. So this is going to be U0 to U6. U6. And next state is also this one. So what is the name of that node? Now I'm going to call this as U7. Am I right? So that is U7. U7. So U0 to U7. Now for the next iteration. So it's iteration number 7. U0 to U7. Now what is the next one? Now what are the remaining nodes? We explored these many nodes. So remaining nodes are among these three only, no? These four. So which one do you think? What is the U3 shortest distance? Sorry, this one. U4 shortest distance is 5. So 5 plus 7, 12. And if you are taking this length. Okay, this is 6. 6 plus u5 shortest distance is 6. Okay, 12. And if you are taking this node, okay, the walk length is 1 plus 1 is 2. 2 plus u7, this is 8. 8 plus 2 is 10. Is that the minimum when compared to the remaining nodes? Am I right?
That below
9
one
is
also we can.
This one, huh?
Yes, sir.
Yeah.
yes, sir.
If I take this one, I can omit this edge, right? So that means 1
Yes.
plus this edge. That edge
9.
u7 is 9. So I think I can select this. 9 is lesser than when compared to all the remaining 3 nodes. Am I right?
Yes, sir.
So
Yes.
this is going to be u8. So when this is u8, so walk length from u8 to u7 is 1. That is the minimum walk length. Okay. So 1 plus shortest distance from u7 to u0 is already 8. 8. 8 plus 1, 9. So this is 9. And the next node is u8. So this is going to be u0 to u8. So updated, this is going to be u0 to u8. Okay, next node, which one do you think? I think this node, I think. Am I right? This is only
Yes, sir.
one edge. So as we are exploring, our task is becoming easier. So u9. So that is what this weight, this shortest distance from walk length. So this shortest distance is 9. 9 plus 1 is 10.
10.
Okay, so sorry. So this is 10. When I say this is 10, the new node is u9. So u0 to u9. Is that okay? Okay, u0 to u9. So what is the next one? Ninth iteration, u0 to u9. And what is the next vertex? If it is u9, I think that this is the only one, no?
12.
So
Yes.
u10. So what is the u10? So which one I'm going to select? Sorry. So which one I'm going to select? So when I say this is u10, what will be its distance? Via which edge I'm going to go?
U9, sir.
V
Via u9,
2.
right?
sir.
So what is u9? See, I have to see. I have to compare. I have to add these. See, this may be 10, but if this edge length is less, okay, then that sum may be lesser. No, I have to see what is L of u4. What is L of u4? 5.
5.
5 plus 10 is 15. What is L of u9?
10.
9.
10.
Sorry.
10 plus 2 is 12. And what is L of u8?
9.
9 plus 4 is 13. Okay, you need to find out the walk length from uh, the vertex to every other node that is existing in Si. Is that okay? Then only you have to decide. See, again I'm telling, there is algorithmic implementation is rigorous. Okay, here virtually you are able to see, that's why you are able to get. Okay, but when you are actually implementing the algorithm, you will be writing for loop, right? For loop or while loop that will explore each and every node, and that will explore each and every distance, and in that it is going to calculate the minimum distance. And after exploring all those things, again it will identify the vertex which is really nearest to the source node. That node we are going to identify it as ui plus 9. Okay, so here it is through u9 only. So that is this walk length plus shortest distance from u0 to the source node. So u9 shortest distance is 9. 10. 10 plus 2 is 12. So this is u10, and u0, u1, and so on to u10. Okay, next iteration is 10, and this 10 is equal to nu minus 1. Therefore, stop. Is it clear? Do you understand now?
Yes, sir.
Okay. Okay. So like that, you can implement the algorithm for the one more homework problem given. Is it okay? May I proceed?
Yes, sir.
Right. So let me stop the recording and start again so that it will have breaks.